All right, exponent notation. Let's write the definition first so that we understand what exponent notation stands for. I know this is mostly going to be review for you, but I want to make sure we have a good solid base before we start getting crazy with our exponents, okay? So exponent notation is when we use, when exponents are used to represent repeated multiplication. It would take, exponents are necessary because otherwise you're going to have to write it out as a long multiplication problem. So if we have a really big exponent on a number, like let's say 6 to the 10th power, if we didn't have that, you would have to do 6 times 6 times 6 times 6 10 times. And that is long, and it also leaves a lot of room for error because you can lose track of how many 6s there actually were. So let's take a look at the notation that we use. Let's do a to the 4th power. Now, when we write this out as repeated multiplication, what we're doing is we're saying we're multiplying a together 4 times. So this is a times a times a times a. So here, a is our base, and the 4 is our exponent. And this over here, we call this expanded form. So let's just take a look at a quick example here. We have 2 to the 3rd power. Go ahead and write this in expanded notation and then solve it. Then tell me what the base is and what the exponent is. Okay. Try that real quick. I'm going to show you an example of that. See, look right here, base is an A. Yeah, it just depends. That's a great question. Okay, so for your expanded notation, for this one, this is telling us that 2 is being multiplied by itself 3 times. So this is going to be 2 times 2 times 2. What does that equal? 8. Awesome. What's the base? 2. Exponent is? Fabulous. Okay. Let's take a look at some that have variables in it too. Now the thing with variables is you're not going to be able to answer this, right? Because we don't know what x is. But if we need to, we can write it in expanded notation. What's that going to be? X times x. And like I said, we can't actually solve that because we don't know what the value of x is. Okay? But what's the base here? Good. The base is x. What's the exponent? Great. Okay. Now let's take a look at a little more complex ones that involve variables. Let's do a squared times b to the fourth. If we write this in expanded notation, you have a multiplied by itself twice. So a times a. And then you have b multiplied together 4 times. So times b times b times b times b. You can't solve this because we don't know what a and b are. But in this case, we have 2 bases. What are our 2 bases? A and b. And what are the 2 exponents?
2 and 4.
Fabulous. Great. Okay. I'm going to have you try one. Okay, write that in expanded notation. X to the third times y. Does anyone want to tell me what they got? Go ahead, Sophie.
X times x times x times y.
Oh, I got ahead of myself. We'll make that an x times y. Good. So you have x times x times x times y. So whenever you don't have an exponent on a number, we always just assume that it's an exponent of 1, meaning it's just itself. Okay. That looks great. Now let's take it the other direction. Let's look at something in expanded notation and then write it using exponential form. Let's start with 2 times 2 times 2 times 2 times 2. Okay, and we want to write that in exponential form. So what is my base going to be? 2. What's the exponent going to be? 5. Fabulous. Okay, it's a nice condensed way of writing it, right? Now let's try one with a variable. B times B times B. Okay, what's my base? What's my exponent?
3.
Fabulous. Okay, now let's do one that involves more than one variable. let's write that in exponential notation. For this one, we're kind of looking at it in chunks, aren't we? We're first going to write this part in exponential notation, and then we're going to write that part in exponential notation. So what's that first part going to be? A to the fourth power. What's the second part going to be? B to the third. Awesome. Okay, if you haven't already, please open up the answer checker. I'm going to do a few problems with you to show you how to enter the answers in. Oh, we should have done some examples like that. That's okay, we'll do it together from the homework. Okay, I think you guys are going to be fine on 1 through 3. When you get to problems 4 through 12, okay, sometimes if it just has the number there, you're going to tell me the value of it. But some of them will say write in expanded notation, use parentheses if needed. So let's look at number 10. Number 10. So I'm going to just put a little line here, and I'm going to show you the work down below so you can see what it looks like in the answer checker.
This one on the paper, right?
What's that?
We're not copying this one on the paper.
You should. Yeah, just so that you have it. Okay, so if you look at number 10 looks like this. And they want you to write it in expanded notation for number 10. Okay, so when you put this in the answer checker, this is this is multiplying by itself 3 times. So what it's going to be is it's going to be negative 2b times negative 2b times negative 2b. Yes, with parentheses. That's why it says to use parentheses if needed. Okay? So this right here is how you're going to put it in the answer checker. No spaces. Okay? No, because it looks like a variable. Yeah, so don't use the x because it looks like a variable. Let's also take a look at number 12. Actually, wait, hold on. No, I think you're fine on number 12. Let's look down at...
Can we do 11?
11, let's see. Yeah, we can do 11. Let's do number 11. 11, it looks like this. Negative 8 y to the third power times z to the second power. You'll notice that in my z's, I always put that like little line in there. That's to show you that it's a z and not a 2, because sometimes z's look like 2's. Okay. Now, the first part of this is very similar to this number 10 here. So we're going to write that out using parentheses. So negative 8y times negative 8y times negative 8y. It is important to use parentheses when you're dealing with the negatives, because if the parentheses aren't there, it looks like subtraction. Because if I didn't have parentheses there, this would look like negative 8y minus negative 8, or minus 8y minus 8y. So the parentheses are really important when you have a negative. But then the second part of this is z squared. You don't need parentheses around just a regular old variable. So we can just write this Z, Z. ZZ. It's that easy.
No. Really?
Yes. So this is how you'll put number 11 into the answer checker. Just like that, no spaces. Yeah, Sophie.
Are we allowed to use calculators for when we like multiply each one?
That's fine.
Right.
Yeah. Michaela.
For like problems 13 and above, how do we use exponents in the answer checker?
That is a great question. I'm going to show you. Yeah, definitely. Which one do you want to do?
I don't know.
Maybe let's do 13 and maybe another one as well. Okay, let's just start with a basic for 13. Okay, this is what the problem looks like. 7 times 7 times 7. And you need to write this in exponent notation. But there is no way to create an exponent in Google Forms. Yeah,
You can use the half symbol.
that's what I'm going to do. Yeah, yep. So this is what we're going to do. What you're going to do is you're going to write your, because the answer is this, right? Okay, 7 to the third power. So what I want you to do is I want you to write it 7, and then use the little hat above the 6. It looks like this. And then put a 3. So we often use that little cap hat symbol just to show that that's an exponent. So that would say 7 to the third power. So this is how you put it in the answer checker, like that. Yeah, Taylor.
For problems like problem 4, do you put parentheses around it, or do we just repeat the number as is?
Problem 4,
Yeah.
you're just solving that one. So what is 4 to the third power? Yeah. Okay, let's take a look at another one. Which one should we do? Anyone have one that they're particularly interested in?
20?
Derwin? 19. Absolutely. Okay. Number 19. This is what it looks like in your homework. Negative n times negative m times negative m times negative m times negative m times n times n times n. Okay, let me show you what it looks like just in regular exponent form, and then I'll show you what it looks like when you put it in the answer checker. So what's your base for the first part here? Negative m, right? Okay, because negative m is being multiplied together 5 times. I do have to have it in parentheses, the whole thing here, negative n, because it's the whole thing that's repeating each time. What's the power on that part? 5, good. And then n times n times n, so my base is going to be what? My exponent will be? 3. Okay, so when you put this in the answer checker, you're going to do negative m cap 5, and then n cap 3, no spaces. So I recommend that you are writing your homework down on paper, showing the correct form, and then just converting that form to this form that goes into Otis, into your Google form. Yeah, Kimars.
What about
Number
number 15?
15. I'm running out of space, so I'm gonna do it over here. Now you can see that the negative is not repeating, right? Okay, so the negative is gonna stay out front, and then it's gonna be 6 to the what power? To the 4th. So then when you put it into the answer checker, it's gonna be negative 6 with the cap 4, like that. Okay, I'm going to let you guys have the rest of the time to work on this. I'm going to come around, so if you have questions about anything, the answer checker or how to solve it, I'm coming around.